Okay, so we're going to look at displacement time graphs here. So that's our goal, displacement time graphs. Often also just called a position time graph, which is actually, I think, almost more accurate. And basically what it is doing is logging in time where an object is. So the first thing I'll do here, I'm going to draw a little number line to kind of keep us grounded as to what we're talking about. So let's imagine we have this, okay, and this is just representing a number line. Put 0 here. What we want to do is we want to log where an object is in time. So let's imagine that we're talking about, I don't know, like a person, okay? Talk about a person. So here they are. And this person is like running around, and they're kind of like running back and forth along this number line, okay? In all different directions. And what we're doing is we're going to log where this person is. So I'm just going to make a little chart here to show where this person is in terms of time. So just bear with me. Okay, so we just made a chart here. So I just made some imaginary positions. Time 0, when we start watching this guy, he's at 4 meters. So he's moving left, correct? He's gone over to 2 meters, then to 0. He's at -2, and he's at -4. Okay. Then at 5 seconds, so here's the times that he's at, so there's 4 seconds. So then at 5 seconds, he's actually all the way back over here. So he must have changed direction and speeded up quite a bit. And then by the last second, he's way over here at +6 meters. So he's gone this way and then zipped back over in this direction. So what we want to do is we want to graph this on a position time graph, because it's sort of hard to keep track of what's going on with this format, right? So if we look, what we'll do is we'll debate on what the dependent and independent variables are. Have you guys taken dependent and independent variables before? You have. Okay, excellent. So usually in physics, in most cases, this is your independent variable. And independent variables are drawn on the x-axis, okay? And then in this case, position, right, is our dependent variable. It depends on time. That's on our y-axis. So when we make our graph, we need to delineate these two axes, and so we'll draw them in here. Now, if you'll note on the graph paper, these aren't all the same size. So this first little square is just like a half piece. So we're gonna like avoid using that because it's gonna mess up our values. And I just want to have enough space to write in my numbers. So I'm gonna go here. And let's actually make it an arrow. And let's make our axes like dark color, black. So there's 1. Okay, there's my y. There's my x. So notice how I'm trying to use as much of this space as I have, right? Now there's one issue that I haven't looked at, and that's that we're going to need some negative values on here, right? So if that's the case, then we have to make sure we leave room to put stuff in the negative, all right? And now we're going to look at our graph, and we're going to see what our values are, and we're going to try to space this out so we use this space as efficiently as possible. So we have 14 spaces, but only 6 numbers to cover. So I'm going to space this out in such a way that we use most of the x-axis, okay? Whoops. 10. So we're going to go every 2. I wish this wouldn't be writing in green, though. Can't seem to make it right in black. I'm not sure what's going on here. Hang on a sec. There we go. Ah, come on. So anyway, sorry, 1 and then 2. And we'll be here, 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 and here. Okay, so this is time 0. This is time 1. Here's 2, 3, 4, 5, 6, and 7. So we'll only go up to 6, but we've used our space fairly well. This axis has to go to a maximum of 6 meters positive, and we have to go to a maximum of -4. So let's see, 1, 2, 3, 4. That'll work there. So we go up by 2s. 1, 2, 3, 4, 5, 6. Excellent. So we have enough space. So we can go up by 2s on this axis as well to maximize the space and how we use it. Lots of times I'll see, people be given a big area of graph paper. Let's make like a little weird graph down in the corner. That's no good, right? The point of your graph is to visually represent what's going on so that you can kind of understand it better. So the more space you can use for that, the better. So here's 1, 2, 3, 4, 5, and then 6 will be, oh shoot, I did kind of run out of space, didn't I? Oh, whatever. Okay, close enough. Maybe I should have shrank it down. Actually, I could probably move this axis down. But since I already have it there, I'm not going to bother. But hopefully you get the idea here as to what I'm kind of after. Okay, we also have to label our axes. So this axis here is position. Hard to write sideways. Position, and in meters. So we have to say what units it's in. And down here we have time, and the units is seconds. Okay? So now we have this pretty well laid out. We can start putting our data in. Oh yeah, and one more thing is we have to have a title as well. So we always write y versus x, or dependent versus independent. So this would be a position versus time graph. Okay, so we have to have a title. Now this is all ready to go. So at 0 seconds, we start at 4 meters. So we're going to start plotting our data points in. That's not a good color. Let's go with this color. So there's 4. At 1 second, we're down to 2 meters. At 0, sorry, at 2 seconds, we are at 0 meters. That's better, okay. At 3 seconds, we're at -2. And at 4 seconds, we're at -4, okay? Now that basically creates more or less a straight line. And then we look at 5 seconds, we're all the way back up to 0. And then by 6 seconds, we're at +6. So like just right about here, just slightly off our graph. So now what we're going to do is we're going to connect that with a straight line to show our motion. So we go here. Then here, and then here. Okay? So we're moving at like all sorts of different speeds here, right? Aren't we? Here we're moving at a negative velocity if you want, right? We're moving to the left. Here we're moving to the right, probably a little bit faster than we were moving to the left. And you can sort of visualize this on your graph based on what these slopes look like. If let's say our data were changed, so this were at 6 seconds, it was only at like say 2 meters, for instance. Say it only made it to 2 meters over here. We could change this around. We could see. Actually, what if it was only at like 1 meter? Say it was at 1 meter. Just so we get some obvious difference here. Okay, so let's say this was at 1 meter, right? For instance. Then this would change. And it would look like, oh dear, it would look like this. It's a light show. Right there like that. So you can kind of tell what your speed is by, how much distance you're covering in a given amount of time, okay? We're going to look at what the slopes of these mean. So hopefully in math class you've covered slopes. But for now, we're just going to kind of make sure that we can draw out a graph properly that's going to, indicate what's happening on a number line throughout time. Why is it that we use graphs, by the way, to show position versus time? How is this giving you information that this is a little bit, less good at doing? What's this kind of showing you that either a, what's that? Yeah. Yeah. So yeah. So what we're kind of getting at here, I guess, is that this is giving you information as to where this is in time space, right? Whereas just looking at like a column of numbers makes it a little bit more difficult to visualize what's going on. And then a picture like this, although it does give you some information, really isn't telling you where this object is in terms of time. Like for instance, if I said, where's the object at, like, 2.5 seconds, you can kind of say, oh yeah, it's somewhere over here. But here you can sort of just look right and you can say, oh, okay, at 2.5 seconds, it should have been at -1. Okay? So you can get a little bit more information, or it presents information a little bit more clearly if you do it in graph form. But these are the expectations I have when you're graphing.